Assalamualaikum warahmatullahi wabarakatuh, and very good day to all of you. So this is the continuation of the method of analysis in the circuit theory. So previously we have discussed on the first method of analysis, which is what we call nodal analysis. So today we will discuss on the second method of analysis, which is we call mesh analysis. So mesh analysis versus nodal analysis. So in nodal analysis, the circuit variables are the node voltage. Nodal analysis applies the Kirchhoff current law to find the unknown voltage. But in mesh analysis, the circuit variables are the mesh currents. So in mesh analysis, instead of using KCL, we are using the Kirchhoff voltage law to find unknown current. Both methods result in a system of linear equations. So for the nodal analysis, we have also obtained linear equations. So for the mesh analysis also, we result in the linear equation. Mesh analysis is only applicable to a circuit that is a planar circuit. So what is a planar circuit and non-planar circuit? So as shown in this slide, here we have the example of planar circuit and the example of non-planar circuit. So as you can see, this is the planar circuit where you will see that this circuit is actually two-dimensional circuit. But for the non-planar circuit, as you can see here, we have what we call a 3D circuit, where we have these loops and another loop that intersect between these loops. So we cannot use the mesh analysis to solve this circuit. So what is a mesh current? So a mesh is a loop that does not contain any other loops within it. So as can be shown here in the circuit, we have three mesh current. Please be noted that mesh current is not equals to branch current. So as you can see, this is what we call branch current. So the branch current number 1, branch current number 2, branch current number 3, and branch current number 4. While the mesh current is actually the overall current that going inside a closed loop. So this is the mesh current number 1, this is mesh current number 2, and this is mesh current number 3. So the direction of the mesh current is up to the analyst, is up to you, okay, whether to use clockwise or anti-clockwise. Plus, but please be consistent. So if you are choosing to use clockwise, so please be consistent that all the loops must be in clockwise. Okay, don't choose clockwise for the first loop and then the second loop you use anti-clockwise. So even though it is correct, okay, you will obtain same results, but it will actually make some confusion during the analysis. So in my suggestion or my advice is actually please be consistent on the direction of the current. So when you are dealing with mesh current, okay, for a single mesh, we will obtain a KVL equation, a linear KVL equations. Okay, so usually we will arrange these linear equations into two terms, which we call the left hand side. As you can see here, is actually the combination or the summation of current and also the resistance of inside the mesh, while the right hand side is actually all the voltage summation. Okay, so this is this example of electrical circuit that can be used to analyze, to use the mesh analysis. So as you can see for the first circuit, okay, we have two loops, which is we have the mesh current IA and the mesh current IB, meaning that you have two variables and therefore you have two simultaneous equation that need to be solved. For the second circuit, as can be seen here, we have four loops. We have mesh current number 1, mesh current number 2, mesh current number 3, and mesh current number 4, meaning that you have four variables, which is I1, I2, I3, and I4. So meaning that you have also four simultaneous equations that need to be solved. Okay, so let's just go to the first circuit to derive the KVL of this circuit. So it is actually compared to nodal analysis, so mesh analysis is much simpler and very straightforward. Okay, so first what we need to do is to have the mesh current IA. So what is the KVL? So this is the mesh current. So we start with the negative V1, okay, plus, so the current is always entering the positive terminal of the resistor. So you have IA R1, and then you have R3 here. Okay, but as you can see, there are two mesh current that going into R3. The first one is IA, which is in this direction from positive to negative, and you have another one which is mesh current IB, which is flow from negative to positive. Okay, but since we are concerning on the mesh current IA, so we assume that the net current that going into R3 is actually from the IA. So we have IA minus IB multiplied with the resistor. Okay, because the current must entering the positive terminal, so meaning that IA is much larger than IB. Okay, so that's why we assume like we arrange like this. And as you can see, after that we don't have any elements, so this one is equal to 0. So we rearrange this, so you will have variables of R1 plus R3 IA minus R3 IB. This is equals to V1. So this is your first equations. So we have already complete the mesh current for IA. Next, we go for mesh current IB. So the KVL of the mesh current IB. So we start with the right now our concern is on the mesh current IB. So as can be seen here, the current must always entering the positive terminal of the resistor. Okay, so the first element is the resistor R3, but as you can see here, we have two currents, which is IB and IA. But since we are concerning on the current IB, so we assume that IB is much larger than IA. So the net current will flow from positive to negative of R3. So we must write like this: IB minus IA R3 plus IB R2 plus V2, and then this is equal to 0. Then we rearrange this one. You will obtain that this one is negative R3IA plus R2 plus R3IB, and then this is equal to negative V2. So this is your second equation. So right now, as you can see, we have two variables, which is IA, IB, and two simultaneous equations. So using your calculator, you will obtain the value of IA and IB. Okay, then from that, you can solve all the questions regarding this circuit. For example, if you want to find what is voltage here, you can always write. So this one, for example, this one is Vx. So what is Vx? So Vx is actually your IA multiplied with R1. Okay, and for example, this one also Vy. So Vy is equals to IB R2. And what about this one? Vz. So Vz, since this is positive, so meaning that we assume that IA is much larger than IB. So, and then since this is, you have two currents, so you must write down IA minus IB multiply with R3. Okay. Okay. So this is the example that I think we can discuss in this pre-recorded video. So the question is find VO. Okay, so find VO. So as you can see, we have three current loops. So we have three current mesh. So the KVL for mesh current IA is, so negative 40 plus 2IA plus you have 8 ohm. So right now, as you can see, we have IA and IB, but since we are concerning on the IA, so IA must be positive. So IA minus IB, and then this one is equal to 0. So we rearrange this one. So you will obtain that this one is 10 IA minus 8 IB equal to 40. So this is your first equations. Then we move on for the KVL for IB, mesh current IB. Okay. So we are concerning on the mesh current IB. So for the 8 ohm here, so the IB must be positive. So IB minus IA plus 6 IB. Okay. And then as you can see, for another 6 ohm here, we have IC also. And the current must entering this positive terminal. So meaning that this one is 6 IB minus IC. And this one is equal to 0. So we rearrange this one. I will obtain that this one 8 plus 6 plus 6. Sorry. And then for the IA is actually negative 8 IA. Plus we have for the B, so we have 14 plus 6, so we have 20 IB And for the IC is negative 6 IC. So this is one equal to 0. So this is your second equations. Okay. And for the third equations, which is IC, okay, so positive like this. So meaning that you have IC and then you have another mesh current IB. So 6 IC minus IB plus 4 IC plus 20. So this one is equal to 0. So we rearrange this one. So you will obtain negative 6 IB, okay, and then positive 10 IC, and this one is equal to negative 20. So right now you have 3 variables and 3 simultaneous equations. So we rearrange this one from 1, 2, and 3. So we rearrange. So this one is 10 IA minus 8 IB plus 0 IC. So this one is actually equal to 40. Okay. And then from 2 is actually negative 8 IA plus 20 IB negative 6 IC. So this one is equal to 0. And then the third equation is we have 0 IA. Okay. So I think we just need to, okay. Don't need to write down because it might be confusing. So IB plus 10 IC. So this one is equal to negative 20. Okay, so by using your calculator, so please choose mode equations. Click 1. So we have 3 unknowns. Click 3. So it is about your A1, which is 10. Your B1 is negative 8. Your C1 is 0 and your D1 is 40. Your A2 is negative 8. Your B2 is positive 20. Your C is negative 6. And your D is 0. And for the third equations, your A3 is 0. Your B3 is negative 6. Your C3 is positive 10. And your D3 is negative 20. So from the calculator, your X is your IA actually. So your IA is 5.6. So IB is 2. And your IC is negative 0.8. So this is all amperes. Okay. So right now we have complete the analysis, okay, or to get the mesh current IA, IB, and IC. So then right now after that, we can actually go to the real questions, which is what is the VO. Okay. Oh, sorry. Okay, so as you can see, if I draw back the circuit, this is 8 ohm, right? So this is your VO. So from here, you can see that you have 2 current mesh current, which is IA, and another one is IB. So we can calculate your VO is equals to, you have 2 currents, okay, IA minus IB. Why I choose IA minus IB? Because the polarity is actually come from is actually at this side. So meaning that IA is much larger than IB. Multiply with 8. So right now we can put your IA value, which is 5.6 minus IB, which is 2, and your volt cut resistance is 8. So this one, so just to go out is just click 1. So it will go up to the, we will out exit the mode. So 5.6 minus 2. So and then multiply with 8. So your answer is 28.8 volt. Okay. Okay, now we continue with another circuit analysis where we have two special cases where we have what to do when we have a current source that exists only in one mesh, and what should we do when we experience or we face a circuit that has a current source that is actually shared between two meshes. Okay, so this is actually the circuit that show for the first case where you have a current source that exists only in one mesh. For example, this one, we have I1 and then I2, and then we have this one is I3. And as you can see, we have current source in I1 and current source in I2, and these current source are not shared with these two meshes. Okay, so what to do? What is the KVL for I1 and what is the KVL for I2? So we go back to the fundamental of the mesh analysis. Okay, so the objective of mesh analysis is to obtain the mesh current. Okay, so right now, if you look carefully inside the circuit, since the current source is not shared with another mesh, so we can say that your mesh current I1 is equals to the current source. So I1 is 4 milliampere. Okay, and for the mesh current I2, okay, so as you can see here, the direction of I2 and the current source 2 milliamperes are in opposite direction, meaning that I2 is actually a negative of 2 milliampere, which is negative of the current source. Okay, so we have, so you don't need to solve the KVL for mesh current I1 and mesh current I2 because it already gives you the values of the mesh current. So right now, the only mesh current that you need to solve is the I3. Okay, so if I go for the KVL for mesh current I3, you will obtain that. So this is positive, negative, positive, negative. Okay, so 4K I2, sorry, not 4K I2. 4K I3 plus okay, I think I will do it in the Word file. Okay, so we have I1 is 4 milliampere and I2 is negative 2 milliampere, and then only the mesh current that we need to solve is I3. Okay, so as you can see, the element for 4 kilo ohms, so this one positive, so this one should be positive because we are concentrating on the I3. Okay, so you have 4 kilo ohm, and then you have I3 minus I2 plus 2K, and we have two mesh current, which is I3 minus I2 plus 6K I3 minus 3 volts, and then this is equal to 0. Okay, then we can arrange this one. Okay, we simplify this equation, so we obtain that we have 12K I3 minus 4K I2 minus 2K I1 equals to 3 volt. But we already know that I1 and I2, we have already got the value, so from here we can solve it. So 12K I3 is equals to 4K multiplied with 4 milliampere. This one will become 16 minus this one also 2K multiply with negative 2 milliampere. So this one is equal to 3 volts. So you have 12K I3 minus 16 plus 4 equals to 3. So this will become 12K I3 minus 12 equals to 3. So, and then this one I think will become 15, right? So 15. So your I3 is 15 over 12K. So by using your calculator, you will obtain that these values is equals to 15 over 12 is actually 1. Hold on. Okay, this one will become 1.25 milliampere. Okay, so the answer for I3 is 1.25 milliamperes. Okay, but the question is actually to obtain the VO. Okay, so to obtain the VO here. So VO, as can be seen here, is actually 6K with 3 volts. Okay, 6 kilo ohm with sorry, I think this one is 3 volt. Okay, 3 volt. So this is your VO. So the current that flow through 6 kilo ohm is actually I3, which is 1.25 milliamperes. So, and it will actually entering the positive terminal of the resistor. Okay. So your VO is actually 6K multiply 1.25 milliamperes minus 3 volts. So by using your calculator, you will obtain this one is equals to 4.5 volt. Okay, another example is actually on the example 2 from the slide. So the question is find P, the power that actually absorbed by the resistor 4 ohm. Okay, so by using the mesh analysis, so we assume that this one current is always we have I1, this one is I2, and this one is I3. So please be consistent. Okay, if you choose clockwise, so every mesh current should be in clockwise. So as you can see here, the mesh current, you have a current source at mesh current I1, so no need to derive the KVL for mesh current I1. So directly I1 is equals to 5 amperes. Okay, and then we move to the second mesh current. So KVL for mesh current I2, so you obtain negative 40 plus 1 I2 plus, right now 2 ohms, we have 2 mesh current, which is I2 minus I1, and then another one is 4 ohm, also we have 2 mesh current, which is I2 minus I3, so equal to 0. And then we rearrange this one, so you will obtain negative 2 I1. Okay, and then this one is 7 I2, and for I3 is negative 4 I3 equal to 40. So here is actually your first equation, and then this is your second equations. Okay, and then KVL for mesh current I3. Okay, so you have 4 ohms, I3 minus I2 plus 8 I3, and this one is equals to sorry, so this one is negative 20. Okay, to 0. So we rearrange this one, you will obtain that this one is negative 4 I2 plus 12 I3 equals to 20 volt. So this is your third equations. Okay, so you have 3 equations with 3 unknowns. So if I arrange this one from 1, 2, and 3, so I can just say that this is 1, 0, 0, so it is equal to 5. And equation number 2 is negative 2, 7, negative 4 equals to 40. And this one is 0, negative 4 plus 12 equals to 20. So by using your calculator, okay, so please choose mode equations, and then 3 unknowns. So you have 1, 0, 0, 5, and A2 is actually negative 2, 7, negative 4, 40, 0, negative 4, 12, 20. So it will give me your I1 is equal to 5. Okay, which is we already know. I2 is 10 and I3 is 5. So I2 is 10 and I3 is 5 amperes also. Okay, so we have already obtained those values. So right now we go to the question. So find the power. Okay, power absorbed by 4 ohms. Okay, so we assume that the current is flowing here like this, so meaning that I2 is larger than I3. Just we assume. So power for 4 ohms is you can just use I square R. Okay. So as you can see, the current, there are two current mesh current. So you need to I2 minus I3. Okay. So I2 minus I3 square multiplied with 4 ohms. So this one 10 minus 5 square 4. So 10 minus 5 is 5. 25 multiplied with 4 is 100 watt. Okay. So that is for example 2. So next is actually the mesh current. What will happen when, as you can see here, for this example, okay, we have a current source that are shared with two mesh currents. So we have I1 and I2. So how to solve this? And then as you can see, for example 2 also, we have a current source that shared with this I1, I2, this and I3. So we have mesh source current that is shared with I1 and I3. So in the next video, I will explain to you. So this is actually what we do is actually to use the approach of super mesh. Okay, so thank you very much.